futuristic weapon that has been under secret development for years.
The Navy has unveiled a new secret weapon. The developers call it a railgun. This new high-tech weapon is smaller, cheaper, and more destructive.
China may have just taken science fiction and turned it into science fact. From reports of aircraft being targeted mid-air to field-tested microwave bursts disabling electronics from afar, we're now seeing real-world energy weapons emerge. This isn't about lasers in labs anymore. It's about systems already in the field, reshaping modern defense tech. In this video, we dive deep into verified cases, dissect the real science behind the beam, and unpack what makes China's pure energy technology a game-changing leap. In recent months, a series of credible incidents has confirmed what many had speculated for years. China's directed energy technology is no longer confined to development hangars or defense expos. It's active. The most headline-grabbing case happened in July 2025, when the German military officially reported that one of its surveillance aircraft was illuminated by a laser from a Chinese naval vessel while flying over the Red Sea. According to Germany's defense ministry, the laser was powerful enough to compromise the mission and force the crew to retreat. In response, Germany summoned China's ambassador, labeling the action unacceptable. While some might think this is a one-off, similar events have occurred before. In 2020, a U.S. Navy P-8A Poseidon patrol aircraft was targeted by a laser from a Chinese destroyer near Guam, prompting official protests. These incidents indicate that laser-based systems are not just being tested, they're being operated in contested air and sea regions. But it's not only about lasers. China has also reportedly tested high-power microwave (HPM) systems in realistic conditions. In April 2025, Chinese scientists announced successful trials of a microwave gun that could fire more than 10,000 bursts without mechanical degradation. The purpose? Neutralizing small drones, disrupting communication signals, and even frying onboard electronics from a distance of up to 3 kilometers. These field-deployable systems include the Hurricane 2000 and Hurricane 3000, unveiled during the 2024 Zhuhai Air Show. More recently, in May and June 2025, footage surfaced showing China's low-altitude laser defending system, LAS, allegedly being used in real time to disable drones in combat zones. While some of this remains speculative, satellite imagery and transport videos have added weight to the claims. The laser unit was even spotted being moved on highways, sparking further speculation about widespread deployment. All of this paints a very clear picture. China's directed energy program is real, active, and capable of creating tangible effects in real-world operations. These are not future concepts. They're part of the current landscape, quietly reshaping how power is projected without traditional force. So what's powering these invisible attacks? Directed energy weapons fall into two main categories: lasers and high-power microwaves, HPM. China has been aggressively developing both, each serving distinct but complementary roles. Let's start with high-power microwaves. These devices emit electromagnetic pulses in focused bursts that can disable electronics by overwhelming their circuits. China's most talked-about system in this field is the Hurricane series. First seen publicly during the 2024 Zhuhai Air Show, these truck-mounted weapons, Hurricane 2000 and Hurricane 3000, are designed for anti-drone defense. Operating at ranges between 1 to 3 kilometers, they use directed pulses to fry circuits in swarms of incoming drones or missiles. In April 2025, Chinese state-backed researchers confirmed lab success with a vacuum-sealed microwave tube, allowing continuous bursts without overheating, a major hurdle in such weapons. These tubes maintain stable output over 10,000 firing cycles, proving the tech is not only powerful but sustainable. The real breakthrough here is mobility. These systems aren't stuck in labs. They already mounted on military-grade trucks and can be deployed across varied terrain. Now, let's talk about laser weapons. Unlike microwaves, lasers concentrate light into an extremely narrow beam capable of burning through surfaces. China's most advanced model is the Low-Altitude Laser Defending System, LAS, which has reportedly been field-tested on drones. Unlike ballistic weapons, lasers move at the speed of light, and can deliver energy precisely to a target with virtually no reaction time. In a widely discussed case, a similar Chinese system was seen operating in Eastern Europe, possibly in support roles. It reportedly melted the casing of commercial drones mid-flight. While not officially confirmed by China, the optics of that moment were clear. Directed energy systems are not just in place, they're being tried in live settings. Of course, these systems aren't flawless. Weather, atmosphere, and power demand are constant engineering obstacles. Lasers, for instance, struggle with atmospheric distortion, rain, or dust. Microwave systems, while more robust in adverse weather, suffer from beam dispersion over longer distances. Still, China seems to have overcome many of these hurdles. The integration of mobile power generators, compact cooling systems, and AI-based targeting platforms has moved this tech from conceptual to operational. Together, these technologies mark a shift from mechanical weapons to energy-based ones, where speed, silence, and precision take precedence over firepower. With terms like pure energy weapons and annihilation before reaction making the rounds on social media, it's easy to think we've entered a Star Wars-like era. But how much of this is grounded in verified data, and how much is just cinematic imagination? While exciting, there's no verified scientific basis or government confirmation for any such weapon operating at those velocities or with that kind of power. Directed energy moves at the speed of light by nature in the case of lasers. But penetration power, not just speed, is what really determines effect. Vaporizing steel or creating instantaneous destruction requires megawatts of sustained power, which current mobile platforms simply cannot produce reliably. However, that doesn't mean the systems aren't dangerous or transformative. Microwave weapons have been successfully used to disable commercial drones midair, and their ability to silently neutralize electronics makes them ideal for environments where stealth is a priority. Even lasers, though not vaporizing anything yet, are strong enough to blind sensors, burn through drone arms, or damage delicate optics, all without triggering explosive effects. So why all the hype? Much of it stems from the ambiguity surrounding the tech. Energy weapons don't leave traditional physical traces, no bullet holes, no blast craters. That makes them perfect tools for psychological influence and strategic deterrence. You can't retaliate against something you can't see or prove happened. This informational gray zone is part of the appeal. It allows countries to project influence without open confrontation. Energy weapons are quiet, deniable, and incredibly fast. A plane hit by a laser doesn't explode, it's forced to land. A drone caught in a microwave beam simply loses control and drops from the sky. Compared to traditional hardware, directed energy systems offer a new layer of subtlety. They redefine engagement, not with force, but with disruption. That makes them not only hard to trace, but harder to deter. And when China appears to be ahead in both development and field deployment, it raises the question, is this a technology gap the world can afford to ignore? We're no longer talking about future weapons. We're witnessing a shift happening in real time. China's rapid advances in directed energy technology are setting new benchmarks, from laser defenses to high-power microwaves. These aren't movie props. They're real, field-tested systems already influencing global dynamics. As the tech gets smaller, smarter, and more precise, it raises critical questions. Who controls the future of invisible deterrence? How do we verify what we can't see? And how close are we to an age where conflicts are shaped more by electrons than explosions? One thing's clear, we've entered a new era of silent, high-speed disruption, and this is just the beginning.